So even though I ordered them several days apart, we just got both PCBs, the Daughterboard and the LiControl, and both stencils at the same time. So stencils are kind of boring. We'll just ignore those for now. Let's open up these. Don't know which one this is. One of them's the Daughterboard. One of them is the LiControl RevA. So here are quantity 50 of these. And honestly, it was only like $20 more to get 50 versus 5. That's why I got 50. There's my prototype one on the floor. So yeah, let's check them out. Put those off to the side. Get rid of that. And grab the one that we splashed onto the floor. That looks pretty good. So you'll notice there's no SMT parts on the top. That's because they're all here on the bottom. It made it quite a bit more compact. So let's go ahead and grab our parts bin here and start stuffing it. So we've got these guys. There's one too many pins on it. So we're going to cut a pin off this. Just kind of make sure everything fits here. So on this first prototype one, I'm going to just leave these taller pins present. Here they are. Because I want to probably probe some of these signals. Probably need to cut one off that one as well. No, that one's the right length. All right, and then we stick our Arduino Nano here. And again, the reason I went with the Nano versus the Every is one, it's in stock, and two, it has more configurable counters because the Nano Every, even though it's a much more capable CPU with more memory, I think it's 3 times more memory, I don't even know, 5 times more storage space, program memory, it doesn't matter. The timers all have the same divider on them, so you have much less control, and also each timer on the Every only has 1 PWM output, whereas on the 328P, you get 2 PWM outputs that have to be running at the same frequency, you know, on the counter, but then you can run each of the 3 counters at different frequencies, and then each one you can set a different count value, so you can have different, you know, PWM percentage or whatever. Anyway, yeah, so that fits, no surprise there. I don't have the 3-bridge connectors here. Whoops, I need to go grab those. And then we've got these 7P connectors here. So basically, these are our man-in-the-middle signals. We're going to cut my mode 1 and 2, command power, ground, 12 volts, the vehicle speed, and then also the wheel speed, the engine speed and the wheel speed, RPM. So yeah, that looks pretty good. The Ethernet connector here goes like that. That looks good too. All right, so that looks good. Anyway, that all looks good on the front. I don't know what I dropped, but that's fine. And the back's all SMT, so yeah, we'll get one of these built up real quick. This should be very, very fast build. Cool, there's our first one, that looks good. Let's look at our second one. This is the LiBCM Daughterboard. And let's get that out. Ah, there she is. Okay, and this one, 30 of them. This is the reason they came at the same price. I'm sorry, the same date rather. They both arrived today, even though I ordered this one much later. Is that up to 30 PCBs is quite a bit faster than doing 50. It's probably the difference between a small and large batch. Yeah, so this PCB, this looks good. So I don't actually have an LiBCM out here, although I do have the raw PCB. So we'll just go with that. So here is an unbuilt LiBCM PCB, and of course it has the fans that go up here, so these basically bolt there. We should make sure all the holes line up. So we have 3 mounting bolts here, 1, 2, 3, and then we need to make sure that all of our connectors down below here line up. That's an important thing to do, and it looks like they do, so that's good. Yeah, 1, 2, and then, oh yeah, it's a different connector. I was like, oh, these don't line up, but this is actually 2 connectors just stuffed really close together. This PCB actually has quite a bit more density than the other one. I actually end up having fuses on the bottom. And I also went ahead and put just a bunch of descriptions of kind of what these things do. You know, and here's the GitHub where you can access it all, just more information on the back. So on the right side here where this fan is, we have a heatsink that's going to mount like this, and this is for the 1500 watt grid charger. This is the blocking diode on the 1500 watt grid charger. This is a safety feature, and so typically you would use a MOSFET so that you had a lower forward voltage drop when you were actually charging, and then you would turn the MOSFET off when the grid charger was unplugged. However, because this is a safety feature, we want to make sure that no matter what happens here, we have an extra element of safety. So that the grid charger is never back powered. That's what this does. The main reason we're doing this is not for safety. It's actually that the grid charger's voltage sense circuitry draws about 10 times more power when the grid charger is unplugged than LiBCM does, so it cuts your standby time by a factor of about 10. So anyway, that's what the main reason here, but then of course there's a safety issue of it as well. Anyway, this won't be populated on this daughter board if you are if you don't have the 1500 watt grid charger. In fact, the whole right side of this won't be populated. The entire right side of this is high voltage. So if you look here with our flashlight, you can see the high voltage isolation layer here, and there's actually some sub isolation as well because we have these fused high voltage signals here. We need to make sure that we had, I believe it was 2 millimeters was our clearance there. So you can see that we have some odd clearance, more higher than you would normally have. It's actually very, I really enjoyed routing this part of it here, particularly because it was almost entirely routed on 1 layer. This is only a 2-layer PCB. In fact, every PCB for the LiBCM project so far has been 2 layers. So this has been 2 layers, this is 2 layers, that's 2 layers. The 47 amp hour boards are 2 layers. 2-layer boards are really cheap, obviously, and they're fun to lay out too because you only have 2 different traces you have to route all your signals on. Anyway, this all looks good. We should make sure everything fits. So our 2 fuses go on the bottom, and they're pretty large. And then of course you have to solder the connectors on first before you solder the fuses, and that's fine. That's a concession just to make this easier, or smaller rather. So there are our 2 connectors for the various things. We have the current, these go to the grid charger on the bottom. On the top is our power from the battery, and then 2 LiBCM. So on LiBCM here, typically you would plug the battery directly into here, but because this also needs pack power, now there will be 2 sets of cables instead of 1, and so the first set will plug into the battery, from the battery to here, and the second one will go from here back to LiBCM, just so that this can power other things. We have the heater control circuit down here, so you have the 47 amp hour heater stuff, and then on the 5 amp hour G3, because this works with both the 47 amp hour FOMOCO and the 5 amp hour G3, this is where the cable that right now plugs in on GPIO 3 and ground will now plug into here if you have the Daughterboard, and if you don't, of course, you'll keep this plugged into there. Sorry, I bumped the camera. We also have a user switch here, which I mentioned before. This is basically just for debug stuff, so that while I'm driving, if I see weird behavior, I can push a user switch, and then that will log that in the data file. This also has the flash memory here, which I believe I have. Yeah, here we go. So here's the flash memory with a header. So I believe this is only 7 pins. So the flash memory will come up here and then go like that. So yep, pins, yes, okay. And you know, why did I use this Adafruit thing versus just rolling my own? Honestly, this is so cheap in bulk. This is only like $7, I think, in quantity, versus me having to go in and solder. This is not a fairly tight pitch part, but this is a very tight pitch. I think it's a BGA. I'm not actually sure. I think it's a BGA. I can't really solder that with the equipment that I have, at least not reliably. And then of course these 3 parts alone cost more for me than just buying the finished part, because you know, Adafruit's buying these probably 1,000 at a time. I'm buying them 50 at a time. So anyway, that fits. That's nice. We've got a tachometer for the fans. I'm not sure if I'm going to keep that. We'll see how it survives. And then the LCD just passes through here. The reason I passed this through, because this is where you typically plug the LCD in here, and I just passed it through. The reason I did that is that I needed more I/O so that we can control this CAN line. So you can see there's a note on the back here that says you can either use the 4x20 display or the CAN board, but you can't use both. That's just because there's some shared control lines there. And of course you can still use Li display. These are all, I'm just kind of rambling here, but you know, whatever, that's kind of what I do. This is the 6-pin header that goes to the LiControl PCB. On the LiControl PCB, I don't actually have a 6-pin header. I'm going to actually use the header that's on the Arduino Nano, and just because, I don't know, it's easy to do that. And so what I'll do is I'll make this to where you'll have to send some kind of command to program it so that you can enable and disable the reset line here. Because you can actually turn off the reset line. The 6th pin on here is the reset pin. So typically you would only be able to use this 6-pin connector here, like that. You typically would only be use that to actually program this. You wouldn't be able to send data on the fly, which is how I want to do it. But you can actually you can disable the reset interrupt. I think you can do that in, yeah, you have to do that in the bootloader. That would make sense. But I don't actually, I'm almost 100% sure you have to do that in bootloader. It doesn't matter, regardless, it's going to work. Not a problem, not even worried about it. But yeah, this is all looking pretty good. Isolation's looking good. It looks good. So we'll get this built up. I don't know what else I have on here. You know, I've got that user switch, tachometer. I'm interested to see if this tachometer circuit works. It's something that I came up with. I wasn't able to find a way to multiplex multiple tack lines into one, because they're just a PWM, you know, high, low as the fan rotates. But I came up with a pretty clever little circuit that I think is going to work just fine. And so basically, if all the fans are spinning, then they're going to have a 50% duty cycle or thereabouts. It doesn't have to be that accurate. And if one fan stalls out, it will either be high or it will be low. It will either be open drain low or it will be resistor pulled up. And so that will basically change that analog value. So I'm measuring 3 tachometer pins with just one ADC channel. I think it'll work. I really think if you went up to like 6 or 7, it'd be much harder. It'd be much harder to do, but with 3, I think that'll work. If it doesn't work, then I'm going to remove it entirely because I don't have the I/O for it anyway, and I'm going to add more control for the 1500 watt grid charger. Right now, I can only adjust the current value, and if this doesn't work, then I will also be able to adjust the voltage, which is a really nice feature for the 1500 watt charger. The other chargers don't have that capability, but the 1500 watt one does. So that's just another safety element that we can add, and I'm all about safety elements. So anyway, that is these 2 PCBs. We're gonna get them built up here real quick. I'll probably start with the LiControl PCB. Whatever, maybe I'll just build them both at the same time. We'll see what happens. More videos to follow. Thanks for watching, as always.